This is an example similar to number 4 in the textbook, section 7.1, in which we want to use the definition of Laplace transform in order to obtain the Laplace transform of a function. In this case, we have to use the definition because we have a piecewise defined function, and we cannot use any of the tables in order to find these Laplace transforms. We have to use the definition, which is given in definition 7.1.1. So the definition says that the Laplace transform is the integral from 0 to infinity of f of t times e to the minus st dt. Well, in this case, I can't just plug in f of t because it depends on the values of t, or for different values of t, I get a different value of f of t. So what I can do is isolate the values, you see, from 0 to 1, for example, where I know what the value of f of t is, and in that case it's 2t. And then I can write the rest of the integral, and then add to it the rest of the values, so it's 1 to infinity, and when t is bigger than or equal to 1, the value of my function is 1, and so I just have the integral of e to the minus st dt. This integral here on the left, for the first one, I have to do by integration by parts because I have the multiplication of two functions. And so I'm going to let u be 2t, dv is e to the minus st, so that du here is 2 and v is minus 1 over s, e to the minus st. Okay, so I'll continue on with my integral here. Then I have uv, which is minus 2 over s t e to the minus st, and that's evaluated from 0 to 1, minus, which will become a plus here, so I have plus 2 over s, the integral of e to the minus st, again from 0 to 1, and that's doing v du over here. And then finally I have here this integral, which is negative 1 over s e to the minus st, and here I'm evaluating from 1 to infinity. Okay, so let's see then. Here first, let's go ahead and evaluate here. Now remember that we are evaluating the t, and so when I put 1 for t, I have minus 2 over s, 1 times e to the minus s, and then I have to do minus and evaluate it at 0 when t is 0. This term is 0, so that stays there. And then here I have plus 2 over s, and then I integrate here and I have minus 1 over s e to the minus st, again from 0 to 1. Now here, if I pull out this minus 1 over s, I have e to the minus s, and I'm going to go ahead and write infinity even though that's not correct, but I'm just thinking of the limit as that variable goes to infinity, even though I'm writing that syntax. And then I have minus e to the minus s times 1. Okay, well, this limit here, because e to the minus s, let me write that over here on the side. This is the same as 1 over e to the s, and then a variable that goes to infinity. So this denominator is getting very large, and 1 over something very large is going to go to 0. So this goes to 0. And then I'm finished over here, and I just have to evaluate this last part. So I have minus 2 over s e to the minus s plus 2 over s. Here at 1 I have minus 1 over s e to the minus s, minus, and then at 0 I get minus negative 1 over s times e to the 0, which is 1. And here I have plus 1 over s e to the minus s. There are some things here that I can combine. In particular, I have minus 2 over s e to the minus s, so I have minus 1 over s e to the minus s plus, and I'm going to keep this in the same way, 2 over s minus 1 over s e to the minus s plus 1 over s. And this is the Laplace transform of our function.